Hey there, we're Group 11, and this is our EEG visualization. My name's Ward.
I'm Blake.
I'm John.
And I'm Nick.
So for our project overview, our client wanted software that could determine the 3D coordinate positions of electrodes on an EEG cap. And our task was to create a 3D visualization of those coordinates, as well as a text file that has those coordinates. So our approach is to use an iPhone app that uses photogrammetry to create a 3D point cloud. Then we upload that 3D point cloud to our Django web application. We process that point cloud and we get the electrode coordinates. And then we use Three.js to visualize those coordinates on the web. This is the sign-up page. You can create an account with a username, an email, and a password, and then that will store the user's individual scans.
So just to take us through a quick demo of logging in on the web, using the website. First, we're going to log in with a newly created user account here. So once we log in, you'll see there aren't any scans yet because we only display the scans uploaded by the current user. And our upload process is more or less the same as it's always been. You select a file. It can be a PLY or PTS point cloud file or a JSON file containing the electrode names and coordinates. You give it a name and you click upload, and then all of this information is taken and stored in our backend SQLite database. So for scans, we store the scan name, the date the scan was uploaded, the coordinates in a JSON format, and the user who uploaded the scan so that we can filter the table here. And once all that information is uploaded and stored in the database, you can hop over to the visualization and see all of the scans here. And as before, you can click and drag, pan around, rotate the scene, and view all of these nodes. But now you can also hover over the nodes and view the coordinates of that specific electrode at the bottom of the screen in red there. And if you need to view all the coordinates at once, you can download them as a text file and view it and store it on your machine as you need. We can also delete scans from the database from the upload page there, and you can see they're no longer shown in the visualization.
So this here is what is the contents of that exported text file that you saw just a moment ago. This was the main ask that our client had for us, basically a column that represents the electrode ID, and then 3 more columns representing the X, Y, and Z coordinates respectively. So for this sprint, what we accomplished was on the back end, adding those user accounts and the associated functionality to the web app and database. We also improved the important performance of the web app as a whole. In deployment, we automated the server setup for our AWS instances using Bash script. And for the front end, as you saw, many of the things in our demo, we created that sign up page and login pages for the users. We also made it so that users can only see their own uploaded scans and delete their own uploaded scans. And in the visualization, users can hover over those electrodes to highlight them and view their coordinates. Lastly, in data processing, we generated an ideal model with the labels that we would expect the nodes to have. And then we started on a rigid transformation registration to label our calculated coordinates against those from the ideal model.
So looking back on the sprint overall, a lot of things went well. We had consistent and productive Scrum meetings, just as the previous sprints, and we extended the actual functionality of our app. Everybody was happy with what they worked on, and the whole process of adding user accounts was a lot less painless than we originally thought it was going to be. And we also resolved many errors towards the end of the sprint that were impacting our performance on the website. Some of the bad things, some things that could be improved, less progress than expected on actually labeling the correct data or associated with each electrode on like an EEG 1020 system. And Polycam, the photogrammetry app that we were using, was generating bad data, and it was too late for us to realize that it had a scaling issue to actually do anything about it in this last sprint, unfortunately. But looking back on the entire project as a whole, some of the challenges that we faced were the learning curve between Django and JavaScript and getting that to work out, and finding the best tools to actually host the web app, as well as time management in this last sprint especially. probably could have gone a little smoother if we, managed our time a bit better, but thank you for watching.